We want to now know what the domain of the function is. So that's what x values can we plug in and get a real number, So not imaginary numbers or not something that's undefined. So domain is always a question about, at this point in time, there are just two things we need to worry about. We need to worry about division by 0, and that's not going to happen because we don't have any fraction here with an x in the denominator, so we don't have to worry about that part. The other part we have to worry about is getting a negative inside of a square root. So that can't happen. So what we see here, what's inside the square root is negative x. We take that out and we say that negative x has to be a positive number or a non-negative, right? So greater than or equal to 0. That would make it positive. So that's all we got to do. Now we just got to solve for x. So this is like -1 times x. So if we multiply both sides by -1 or divide by -1, either way will work, however you want to think of this. But whenever we multiply or divide by a negative, what's going to happen when we have an inequality is it reverses the direction of the inequality. And I just don't want you to memorize, okay, that, we'll multiply by negative times negative is positive, 0 times negative is still 0. So now x has to be less than 0. Does that make sense? If you put in a negative value for x, a negative times a negative becomes positive. That sort of makes sense. But I also want you to think about it. If you have 2 is less than 3. I just made this up. Just two numbers. It doesn't matter which numbers you use, but one is bigger than the other, right? 3 is bigger than 3. Sorry, 3 is bigger than 2. And now what happens when you multiply these or divide them by -1? We get -2 and we get -3. And on the number line, -2 is to the right of -3. -2 is bigger than -3. That's why we have to reverse the symbol. So I just, that's for your understanding. You always try, a lot of times the principles of mathematics can be understood best when you just use numbers that you know are going to happen. We don't know really what x is, right? It's variable, it's abstract, and so we might forget to do this. Anyway, so the other trick I use, I don't know if it's a trick or not, but it's I like to write out a number line when I'm doing interval notation. So what is x? It's some number that's related to 0 is a boundary point. So I'm going to put that there. Since it's got the possibility of being, and again, it could be anywhere, it could be equal to 0. So what goes there? A big solid dot, which means we're going to have a bracket with it. But which way do we go? X is smaller than 0. What way? That means you're going to the left. You got to go this direction. So this helps us get the direction down. We know with 0 we're going to have a bracket because it's included. Infinity is sort of like never included. So notice when you do this number line, it is setting up the direction and everything for your interval notation. And you can even get your symbols in there. And so now I can choose the right symbol to use. I've got a parentheses and a bracket. That's that one. I'm going to put in negative infinity going to 0. 0. I have to enter that on my keyboard. There we go. That is the answer to that one. Okay, so use those tools. Again, there's only two possibilities whenever we're talking about domain. Later on, when we get to logarithms, we'll see that'll add another thing for domain, but that's in Module D. But for right now, these are the only two things. You see the word domain, find the domain. These are the two problem childs that we have. Everything else is going to be, there is nothing we have to take out of the domain. Everything else, sort of where we always start with thinking the domain is everything, which is negative infinity to infinity. And then we have to reduce it by the numbers that won't give us, that give us either an imaginary number or they give us division by 0, which is undefined. Those are just the two things when we're talking about domain. All right, let's keep on moving forward.